Okay, kids, let's move from the radius of convergence to the interval of convergence. So let's remember and kind of like wrap up what we did the last video. Recall that if a power series converges, we use like kind of the morphed numeric ratio test for convergence with x's, but we osmosis the x's outside of the limit situation. And we do the ratio test to give us if the power series will converge only at the center, the point of tangency, when you plug in that center for x and no other x's will work, right? So if I say this is my center for my power series, there's the power, there's the, right? And maybe the function is up here. There's my point of tangency. And where does my, right? Where does my power series match the function? Or where do I get convergence? Only if you plug in x. Or the best scenario is that no matter what number I plug in for x, I have an infinite, a bag with infinity x's that I can plug in, right? So this is worst case. This is the best case. And then, of course, if I can't have all x's, well, then I still have a bag with infinite x's in it, but within a given interval, right? And what is that radius around my center? Right? There's my radius of convergence. How far right and how far left can you go without including the actual endpoints? Can you go? What distance can you go from the center, right and left? That's the radius of convergence. So that's either a number or an infinity. And that number might be 0, which is the worst case, right? Radius of convergence 0. Radius of convergence is infinite. Radius of convergence is 2, 4, right? The radius of convergence would never be negative, right? All right, so that's what we did last. In your handout were all problems that practiced doing the ratio test and coming up with a radius of convergence that it was either infinity, 0, or a number that was not 0. Worst, best, or okay situation. But the endpoints for the radius of convergence only tells you how far you can go without actually hitting the endpoints of each one of those intervals. So I can go a distance of just up to 2, but I can't actually go a distance of 2 to the right or 2 to the left if my radius of convergence is 2. So what if they ask me about the endpoints? So I need to give you some directions. When they say find the open interval, that is another way of asking you for the radius of convergence, right? Because after all, if I tell you that the center is 0 and the radius of convergence is 2, well, then that's the same thing as giving you an open interval from -2 to 2, surrounding the center 0, right? So the open interval of convergence is the radius of convergence. So look at this power series, find the power, that's in your x. I did the ratio test with this, and if you don't believe, we did the ratio test in the last, on your homework handout, and in the last video, I'm not going to do the ratio test, but I did the ratio test. Did the RT work, and I found that my radius of convergence was 4. Which means from my center, and what is my center, can you tell? On x, there is no shift. Therefore, my center is 0, and I can radiate out to the right and to left 4 units, but you can't go exactly 4 steps to the right or the left. You can just go right up to those walls. If I pick any number between -4 and 4 and plug it in for x, I get a numeric series that is guaranteed to converge. That's the power of the ratio test for power series. But I don't know about -4 and I don't know about 4, the endpoints. So what you have to do then is you have to do work from previous sections, the beginning of series, or if you can think about it, pre-cal work. So what happens if I plug in -4? If I plug in -4, I do not have a power series anymore, right? That's, oh, don't forget the n is right there, -4 to the n. So that is my series. So if I plug in -4, what does that do? That makes my series look like this. N over 4 to the n times -4 to the n. So take, starting at 1, replace n with 1, and write me out a couple of terms. My power series is now numeric, right? As soon as I put the -4 in there, see the -4 in place of x, right? I don't have a power series anymore. I have a numeric series, and I'm going to use my numeric series thought process on it. So the first thing I'm going to do with the numeric series is see if the limit of my terms go to 0, right? That's the nth term test for divergence. If my terms do not go to 0, my numeric series diverges. Remember, if you fail the nth term test for divergence, you may still diverge or converge, you just don't know. So the next thing you say to yourself is, well, is it a geometric series? If it's geometric numeric series, I just have to find the common ratio, see if its absolute value is less than 1. So remember when I referred last time to a list of convergence tests. Your list of divergence tests has only one test on it. There's only one on it, and this is it. But your list of convergence tests is much longer. Geometric. If the absolute value of the common ratio is less than 1, the given numeric series will converge. That's the geo series test for convergence. Is it a p series, right, where all my terms are positive? As long as p is greater than 1, strictly greater, remember, then the series will converge. That's the p-series test for convergence. Remember, we did the same kind of thinking with when we were doing improper integrals. Remember, I told you that's why we put improper integrals at the beginning of this unit, because the same type of convergence test you use on an improper integral is what you use on numeric series. If my series is very similar to a geometric or p-series, and I want convergence, then I only care about finding a bigger and similar series with positive term that converges. If the bigger series converge, then my similar known one converges as well, because the bigger one is on top and it is known to converge. That is the DCT test for convergence. I'm not interested in testing for divergence. Can I find a similar series with positive terms that I know converges? I don't know if I don't care if it's on top or, which one's bigger, or I can't figure it out, then I do the limit comparison test for convergence. Again, I'm not trying to find divergence. I'm only looking for convergence for each endpoint. Is the limit of the absolute value of the ratio of consecutive terms less than 1? That's the test we just learned. That's the ratio test for numeric series for convergence. Remember this one, if you're exactly equal to 1, then you don't know. You have to go back to and do a different test. And then this again is cycling back to the beginning. We have something called the improper integral of the series. If you take a series and turn it into an improper integral, and you can evaluate the improper integral, right? Which means you can integrate and get a number. then that's the integral test for convergence, right? I'm not interested in when an improper integral goes to infinity because that's divergence. That's the integral test for convergence. And there are others, right? There's an nth root and square root. I don't know. I don't remember. Anyway, there are others, but these are the most common. So if I am asked if a given numeric series converges, these are all the things oh wait, sorry, I forgot. I have another test. The alternating signs test. If you did this in pre-cal, you probably don't remember it. If you have a series, here's your terms, but you also have a sign alternator. If each term is positive on its own, in other words, the only way you get negative terms is with your sign alternator, and each term is smaller and smaller as you go along, and the limit of the terms is going to 0, then the series will converge. This is basically, remember the nth term test for divergence where I kept telling you just because your terms go to 0, it doesn't mean you converge? It does if you're an alternator, right? So really, all you need to remember is this. If you have an alternating series and the limit of those terms without the alternator goes to 0, then your series will converge. If you just have a bunch of positive terms and the limit of the terms goes to 0, you don't know. But as soon as you alternate, bam, you have convergence. That's the alternating series test for convergence. Put that on your list. So again, if I am asked if a given numeric series converges, this is what all of the things I think of. But finding the interval of convergence for a power series means this is what you do at the end. After finding the radius of convergence, you plug in the endpoints and you do pre-cal, or you do the beginning of this unit work, where you look at the numeric series and run the nth term test for divergent on it first. And then you think of all of these, your geometric, your P series. Is it like geometric or P series? And I might want to do a comparison. Is it alternating series? Obviously, don't do an alternating series test unless you have the sign alternator. Or do I have a ratio test? And remember, the ratio test is when you have factorials, when you have exponents, when you have lots of powers. Alternating sign test is if I have a sign alternator. P series is if I'm 1 over x to the p. Geometric is if I am a times r to the n. And then my comparison tests really are used to compare to something that's very similar to a P series or geometric. Yes, there's the integral test and the nth root test or whatever. They're just not as common, so I didn't add them here. So let's go back to the problem I was doing, right? Here was my given, this was my given power series. So the directions were find the radius of convergence of this power series. I saw the power. I saw that the center was 0. I did the ratio test, right? The kind of morphed ratio test for the power series where I did my n plus 1, n plus 1, n plus 1 multiplied by the reciprocal, canceled, enabled me to osmosis the x to the outside, and I did my inequality work, and I found that the radius of convergence is 4. Stop if that's all they ask you. If they ask you for the radius of convergence or the open interval of convergence, stop. But if they ask just for the interval of convergence, you have to go further. You have to say, oh, well, this means, think about your center being 0, and then convert your radius of convergence to an open interval, -4 to 4, and then use numeric series tests to see if you can close either one of these ends. So you put -4 in, expand the series. So I have n is 1 over 4 to the 1 and negative 4 to the 1. 2, 2, negative 4, 2. 3, 3, negative 4 to the 3. Expand that out. Look at your terms. My signs do alternate. So I'm thinking the alternating series test, but before I even looked at the alternating series, I thought about the nth term test for divergence. Do these terms go to 0? No. This numeric series, after I put the negative 4 in for x, does not converge by the nth term test. That means that this open interval will stay. Let me make it red so I know I've done my work. That interval stays open. So what are you going to do now? Repeat with the right endpoint. So take that negative 4 out and put a 4 in. Now remember, there's the n there. My little my little red box covered it up. So repeat. N is 1, 4 to the 1, and 4 to the 1. Right, what does that look like? This series also, this numeric series is not an alternating one, but the series does not converge also by the nth term test. Therefore, what does that say about the right endpoint? The right endpoint stays open as well. Therefore, the radius of convergence is 4. The interval of convergence, they asked for an interval, so freaking give them an interval. And you can do it in this. This is also, right? Multiple choice would look like this. So you can use the soft bracket, hard bracket versus the in-quad, but it is an interval of convergence. So do just give them the interval, give them an interval in either inequality or this closed bracket, open bracket notation. Whereas the ask for the radius of convergence, remember that is just a number or an infinity sign. Now notice this work, I could have done algebra on this instead of just expanding terms like this. Here's what I could have done. I could say, okay, hold the phone. That's n, and that's 4 to the n over 4 to the n, right? But 4 to the n over 4 to the n, so that sum, that is just n. You can pretty much can tell from there that my terms are not going to go to 0. I could do the same when it's negative 4, right? Remember, I can write negative 4 to the n as negative 1 to the n times 4 to the n over 4 to the n, and then still times that n. The 4 to the n's would still cancel out, and I would end up with the sign alternator times n. But again, I think you can pretty quickly see that those terms, even with the sign alternator or not, those terms do not go to 0, therefore diverge. All right, so let's take some notes on this. If you're asked for the radius of convergence or the open interval of convergence, then you either recognize you have a geometric or it's sine or cosine or e, which they're not going to do. They're not going to give you those, right? It's geometric, or you use the ratio test. And remember, AP loves, you're going to do the ratio test on free response somewhere, I swear. Ratio test for power series. However, if you are asked for the interval of convergence, not open interval, just interval of convergence, then first you find the radius of convergence using the ratio test. Then you put the left endpoint into the power series, and you now have a numeric series. You always check the nth term test first. It's the fastest and easiest test, and if it's divergent, you're done. However, if the limit of your terms does go to 0, then decide which of those convergence tests to use, right? All those things in the thought bubble, right? The thought bubbles. Is it p-series? Is it geometric? Should I do a comparison test? Is it alternating signs? Should I use the alternating signs test? Right? All of those things. The ratio test for numeric series could use as well. Then you repeat for the right endpoint, and then you decide, that means you have another numeric series, and then you use inequality notation and you figure out whether you should include the endpoints in the inequalities or not. That's the whole goal of the interval of convergence, right? So it's kind of like the hokey pokey. After you do the ratio test, put the left endpoint in and check it all out. Then put the right endpoint in and check it all out. And then you do the hokey pokey and write the inequality notation. Okay? All right. So your book sums this up as well, just without the hokey pokey reference. So this is the procedure for determining convergence of a numeric series. So this is after you've done the ratio test for power series and gotten the radius of convergence. Notice the nth term test is first. If the limit of your terms does not go to 0, then you definitely diverge. If your limit of your terms does go to 0, or maybe I think it goes to 0, then you start looking at, is it geometric? Is it a p-series? Is it similar? So you would do comparison. These are the others that I talked about, right? The integral test I talked about, the ratio test for numeric, the nth root test, right? These are not as common as these ones. The nth term for divergence, then geo and p series, and this one. If you have an alternating signs and it doesn't already diverge because of the nth term test, then just say, oh, with the alternating signs, if the signs alternate and the terms do go to 0, then I converge. Okay. And then I love what the book says here. Oh, you can do what with partial sums or consult more. Yeah. Nah. AP will not do this. AP will do this, or this. They generally, it's not that the ratio test is not common, it's just that you're already doing the ratio test on the power series, so they're not generally going to make you do it again, right? And I have not seen the integral test on the AP exam. And I certainly haven't seen the nth root test. Because again, the integral test, you're really doing an improper integral. So they're going to test you there on that. All right, let's do an example. This is, by the way, page 521. So look at these directions. This was last night's homework. Find the radius of convergence. The radius of convergence is either a number or infinity. Right? Sometimes that number is 0. That's the worst case. Sometimes that number is not 0. That's an okay case. Sometimes you get an infinity, which is the best case because it means you have an infinite radius of convergence around the center. So the first thing I want to make sure of, and again, hopefully, if they're asking you for the radius of convergence, it better be a power series. Right? So yes, I see an X, so it is a power series. Again, I'm not going to do the ratio test work. We did that before. I'm just giving you the answer. This power series radius of convergence is 2. So I did the ratio test with the power series, right? Did my n plus 1s all over the place, multiplied by the reciprocal with just my n's, canceled with my x's to osmosis my x to the outside, ignored the sign alternator while I was doing that ratio test, right? Because the ratio test means absolute value. Make sure you write absolute value. That's important in the setup. I did my limit work. I evaluated the inequality. I got the radius of convergence is 2. What's my center? The center is 0. Do you see that? Right? There's no shift on the x. So my center is 0. So I'm thinking to myself, self, with 0 in the middle, I can radiate 2 units to the left, 2 units to the right, but I don't know about those endpoints. I don't care about the endpoints though. If they just ask me for the radius of convergence, I stop here. But if I am asked about the endpoints of the radius of convergence, they won't ask me for the radius of convergence. They'll ask me for the interval of convergence. And then I have to take -2 and plug it in for my x. So what happens when I do that? Let's do some work on that. So split this up so that you have another -1. So I have -1 to the n plus 1, -1 to the n, and 2 to the n. Do you see where I did that? Right? So this is really, what is -1 to the n plus 1 times -1 to the n? This is odd, which means all of my terms are negative, right? This is not a sign alternator anymore. Do you see that? These are going to cancel out, and that's 1 over n. So what do you know about the series, the numeric series 1 over n? Now, remember, my signs are all negative, always negative. This is not a sign alternator anymore, so I can just do this, morph my -1. I don't need the 2n plus 1 anymore, because 2n plus 1 means -1 to odd numbers is always -1. And now look at 1 over, what do you know about 1 over n? Diverges because it is a p-series where p is equal to 1. And if my p-series diverges, -1 times a divergent p-series is still going to diverge. So what does that say about the bracket on -2? It's going to stay open, right? So I'm running my pre-cal numeric series tests. Put the left endpoint in, shake it all about. Now what? Put the right endpoint in, shake it all about. What happens when I shake it all about? I have -1 to the n plus 1. 2 to the n cancels with 2 to the n. This is a true sign alternator now. I can't, right? N plus 1 is going to be even and odd, so my signs are going to alternate. What's true about these terms? These terms go to 0, and I have a sign alternator. Therefore, this series converges by what? The alternating series test. And what they're going to want to see is that you know the terms go to 0 with a sign alternator. So what does that say, though, about the bracket over with 2? So I put the left endpoint in, I shook it all about, and I found out that I had a divergent numeric series. So don't use negative. You can't, -2 is out your bag. But what about 2? I put 2 in to the power series, made it numeric, shook it all about, and found out that I got convergence. So I get to close that bracket, right? So 2 gets to stay in the convergence bag. This power series interval of convergence, right? And this time I wrote it, but this notation is this is full credit. And this is full credit. If this happened to be a multiple choice, this answer is what you will see a multiple choice. They will write it in inequality notation. But do you see that I have the equal sign on the endpoint that I plugged in and got convergence? I have no equal sign with the endpoint that I plugged in and got divergence. That's the difference between finding the interval of convergence and the radius of convergence, right? Radius of convergence is less work. That is the homework from the previous video. When you look at the homework handout for this video, it's got the exact same problems as the first handout. The title is different though. So what that means is your previous homework, you did the radius of convergence for all of them. And now you just have to do the interval of convergence. So for this handout, you take the last handout and you ignore any radius of convergence that is equal to 0. There is no interval, right? Or any interval of convergence that is infinity, right? Because you can't close infinity. Negative infinity to infinity is your interval of convergence. There's no closing it. But if your radius of convergence is a number that is not 0, then you need to do pre-cal, right? So the homework that goes with this video is all prior knowledge. The only thing you're doing is taking the endpoints of your radius of convergence, plugging them in for x, and creating two numeric series, seeing if they converge with all your convergence tests, and then either leaving your bracket open or closing it. Sometimes you're open on the left and closed on the right. Sometimes you're open on the right and closed on the left. Sometimes you're closed on both. Sometimes you're open on both. Okay. And we will do more of this in our next live session. Whoops, I forgot I had another example. I wanted to do an example where your center wasn't 0. Do you see what your center is here? Right? So your center is 3. The radius of convergence will tell you how far you can go right and left, but they want to know the interval of convergence. So that means you have to test the endpoints. So once again, I am not going to do the radius of convergence. Oh, yes, I am. I got a radius of convergence of 1. Sometimes I forget what I type out, right? I set up, and I remember why I wanted to do this. I, again, wanted to highlight, please don't lose setup points. Make sure when you are doing the ratio test on power series, you know that you indicate that you know it's a limit, you indicate you know its absolute value, and that you know that limit has to be less than 1. The math you do in between there to get to here might have no points with it, depending, or might just have 1. But notice you are just using math and simplifying. Then you're evaluating the limit. This limit is, right, the ratio of the leading coefficients, because the power is the same. 2 over 2 is 1. So I had x minus 3 times this limit, which was 1, had to be less than 1. Therefore, the radius of convergence is 1. So that means that from the center 3, I can go right 1 and left 1 and create an open interval of convergence, right? What would that be? That open interval would be 2 to 4. Now to find the interval, I have to decide whether 2 and 4 make individual convergent or divergent series. So the endpoints means you're going to test numeric series. So replace x with 2. That is the left foot in. I got negative 1 to the n over 2n. which is really more osmosis out that 1/2. Here's your sign alternator. And then you have 1/n. So you have terms go to 0. And you have a sign alternator. Therefore, converge by the alternating series test. So you put the left endpoint in, you shook it all about, and you found out convergence. So that means you're going to close that left end. Now you're going to put the right endpoint in and shake it all about. Again, you're going to osmosis the 1/2 out. 1 to the n is just 1, right? So you have 1/n. These terms do go to 0, but there is no sign alternator, so you can't use the alternating test. The nth term test for divergence is inconclusive. But then I recognize that this is a p series. Where p is equal to 1. Therefore, diverge. And again, 1/2 times a convergent is still convergent. 1/2 times a divergent is still divergent. So you put the right endpoint in, you shook it all about, and you got divergence. So you're going to leave the right endpoint open. So the interval of convergence, again, remember, we did the radius of convergence, and we got the radius of convergence to be 1. So with a center of 3, you're allowed to go 1 unit choose any x in there up to 4, but you cannot include 4. You can go left 1 unit all the way to 2, but you are allowed to use 2, and you will get a convergent series. I don't need to test any of the other numbers in here. I know I will get a convergent series. Okay, now I can say, and we will do more examples in our next live session. Don't forget for your homework, this handout, you've done all of the work of the ratio test on the power series on the first handout. They're exactly the same numbers, right? Exactly the same values, problems. Okay, all right, I will see you soon.